problem in the areas of engineering. Supersonic Odyssey roller coaster, which is located at Berjaya Times Square theme park in Kuala Lumpur, Malaysia. The polynomial roller coaster function with equation is 5x equal to x power 3 minus 6x power 2 plus 9x plus 4. In designing a well-functioning roller coaster, you must consider the following, which is speed, slope, maximum and minimum height, and so on.
Okay, next we go to question 1. The function for question 1 is x cubed minus 6x squared plus 9x plus 4. And first derivative, we will get 3x squared minus 12x plus 9. And second derivative, 6x minus 12. Okay, to find x and y intercept, we will use this equation, and we will use scientific calculator. By using scientific calculator, you will get x equal to negative 0.3553. You take 4 decimal place, and x-intercept is negative 0.3553. When we find y-intercept, we use x equal to 0, and we substitute 0 in this question, and we will get 4. For y-intercept, we will get 4, and the coordinate is 0, 4. The roller coaster was at ground level, coordinate 0, 4. For second question, we will find critical point. Critical point f prime x must be equal to 0. So we will use first derivative. So 3x square minus 12x plus 9 equal to 0, and we factorize, and we get x minus 1 and x minus 3 equal to 0. Okay, to find y, we will use 1 and add this and substitute in fx question, and we will get 8. When x equal to 3, sub in fx question, you will get 4, and the coordinate 3, 4. Okay, according from this question, we find maximum and minimum points. To find maximum and minimum point, evaluate second derivative at 3 and 1 to determine whether it is maximum or minimum. So second derivative equal to 3, and we take second derivative and sub 3 in that function, and we will get 6. 6 is more than 0. Next is we sub 1 in second function, and we get negative, and negative 6 is less than 0. And so after we get 6 and we see this question, and 3, 4 is a relative mean point, and 1, 8 is a relative maximum point. The relative highest point is 1, 8, since the first hill of a roller coaster is always the highest point in point. This also absolute maximum point.
For the question 3, we need to find increasing or decreasing interval. So this is the reason that we need to find increasing or decreasing interval. This is our function, so we sub 0 into this function, so we get 9 that is bigger than 0, which means that fx is increasing in the interval which is from -infinity to 1. The second reason is we sub 2 in this equation so that we can get -3, which is smaller than the 0, which means fx is decreasing in the interval from 1 to 3. The third step is we sub 4 in this equation, so we get 9 that is bigger than the 0. So fx is decreasing in the interval from 3 to the infinity. In terms of distance along the graph from start x equals to 0, we can know that the roller coaster path increasing in the interval from 0 to 1, and the roller coaster path decreasing in the interval which is from 1 to 3, and decreasing and increasing in from 3 to infinity. For the fourth question, we need to find inflection point of the roller coaster. So we set the second derivative of fx equals to 0, so we get s equals to 2. Then we sub 2 in the equation, so we get y equals to 6, which means that 2 and the x axis is 2, y axis is 6, is the inflection point of this curve. That so the roller coaster will obtain the greatest speed at this point.
In question 5, we need to determine the concavity of the curve. So from the previous question 4, we notice that inflection point is s equal to 2. So we get the s equal to 2 in this place. So we find that there are two reasons of this curve, of this curve. There's first reason and second reason. We set s equal to 0 in for the first reason, and the s equal to 4 is second reason. So we just sub the value into the second derivative. That is f. There's 6s minus 12. The first reason is -12. The second derivative of 0 is -12. It means that this will lower than 0. So f function is concave down in the interval from -infinity to 2. In the second reason, we sub the s equal to 4 into the second derivative. Get the answer is 12, which means that the function is greater than 0. So the function is concave up in the interval from 2 to infinity. So we need to answer this question. We need to state that in terms of distance along the graph from start, s equal to 0. S equal to 0 is the starting point. So the roller coaster path concave down in the interval from 0 to 2. We know same with the -infinity is the 0. So the second one is the roller coaster path concave up in the interval from 2 to infinity. The question 6 needs us to draw to sketch the graph. So we need to combine all the results from the previous question and need to determine the information about the graph. So you can see this is the graph. So x-intercept is -0, 3.553, 0. Y-intercept is equal to 4, that is this point, 0, 4. Critical point is, maximum point is 18, minimum point is 34. So you can see in this graph, we have stated clearly that the maximum point is 18 and the minimum point is 34. So the next is we need to determine the curve, the scale of graph. So f is increasing in the interval from -infinity to 1. We cannot draw until infinity, so we stop at the x-intercept. So the net is f is decreasing in the interval 1 to 3. So we can see x equal to 1 and x equal to 3 is decreasing interval decreasing. The third is f increasing in the interval 3 to infinity. So from this to until infinity, the f is under the increasing interval. So the next is the inflection point 2 and 6. That's here. The roller coaster will experience the highest speed at this point. The last one is the concave up, down, or up. So in this curve, in this graph, we notice that this down and this up. F is concave down in the interval from negative infinity to 0 to 2. And then F is concave up in the interval from 2 to infinity. Concave up. So actually this is the first curve of the roller coaster, because we notice that the curve of the roller coaster is not the same for all, so the whole journey. The starting point is 0, 4. We said the starting point is 0, 4. This means that the customer will into the roller coaster at the point 0, 4. This is the ground from the land. So this is the whole curve. Thank you.